Assignment statements. Assignment statement is one of the central constructs in imperative languages. It provides the mechanism by which the user can dynamically change the bindings of values to variables. Assignment statement sets and/or resets the value stored in the storage locations denoted by a variable name. In other words, it copies a value into the variable. Assignment statements. Assignment statement is one of the central constructs in imperative languages. It provides a mechanism by which the user can dynamically change the bindings of values to variables. Assignment statement sets and/or resets the value stored in the storage locations denoted by a variable name. In other words, it copies a value into the variable. Simple statements. Nearly all programming languages currently being used use the equal sign for the assignment operator. All of these must use something different from an equal sign for the equality relational operator to avoid confusion with their assignment operator. The design in some languages such as Fortran and Ada, an assignment can appear only as a standalone statement, and the destination is restricted to a single variable. There are, however, many alternatives. Here we have an example for Java as simple assignments. Int num equals 1, boolean check empty equals false, string topic equals quote simple assignments unquote. For Prolog, we have num a parenthesis 1, num b parenthesis x if x is 1, name parenthesis Dominic, name parenthesis Narilim, simp parenthesis Dominic. Here I will show you Prolog simple statement examples. First we will write num a 1. It states that num a has a value of 1. Next we will put num b and put the x variable there. So we can say if x is 1. This declares that x is 1. It assigns a value. Is basically the equal operator in Prolog. And so if we put it in the query, num a, and we put the 1 there, we'll say true because num a is 1. If we put x there, it will say that x is 1. For num b, if we say 1, it's true. And if we put x there again, we'll say that x is 1. Conditional targets. In computer programming, colon is a ternary operator that is part of the syntax for basic conditional expressions in several programming languages. It is commonly referred to as the conditional operator, inline if, or ternary if. An expression a b colon c evaluates to b if the value of a is true and otherwise to c. One can read it aloud as if a, then b, otherwise c. Although many ternary operators are possible, the conditional operator is so common and other ternary operators so rare that the conditional operator is commonly referred to as the ternary operator. Here we have an example for C, C++, and Java. Int c is equals to x a colon b. Int c equals parenthesis a greater than b a colon b. Here I will show you an example for conditional targets on C. Here I initialized both a and b as 1 and 2. I also initialized bool x to be true. And here we will see that I wrote int c equals x a colon b. It means that if x is true, a will be, or 1 is the one that will be assigned to c. Or if x is false, b will be the one to assign to c. C will be 2. And since x is true, c will be 1. Over here, d is equals to a greater than b a colon b. If this is true, A will be outputted for D. If it's false, B will be the one assigned to D. And here, I will print both C and D. So let's run it. And here, it shows that C is 1, which means because X is true, so A or 1 is assigned to C. So it's outputting 1. As for D, since A is clearly less than B, so B will be the one assigned to D, which is 2. And so therefore, the output is 1 and 2. Compound assignment operators. A compound assignment operator is a shorthand method of specifying a commonly needed form of assignment. The form of assignment that can be abbreviated with this technique has a destination variable also appearing as the first operand in the expression on the right side, as in A equals A plus B. Compound assignment operators were introduced by ALGOL 68, were later adapted in a slightly different form by C, and are part of the other C-based languages, as well as Perl, JavaScript, Python, and Ruby. The syntax of these assignment operators is the catenation of the desired binary operator to the equals operator. For example, sum plus equals value is equivalent to sum equals sum plus value. The languages that support compound assignment operators have versions for most of their binary operators. Here we have an example for C, C++, and Java. Double A equals 1, then A plus equals 2. Here I will demonstrate compound assignments on C++. As you can see, I've already initialized A as a double with 1. Then I wrote A plus equals 2, which means A is equals to A plus 2, and A is 1. So therefore the output must be 3. And here you can see that it is correct, the output is 3. Unary assignment operators. The C-based languages Perl and JavaScript include two special unary arithmetic operators that are actually abbreviated assignments. They combine increment and decrement operations with assignment. The operators plus plus for increment and minus minus for decrement can be used either in expressions or to form standalone single operator assignment statements. They can appear either as prefix operators, meaning that they precede the operands, or as postfix operators, meaning that they follow the operands. In the assignment statement, sum equals plus plus count, the value of count is incremented by 1, then assigned to sum. This operation could also be stated as count equals count plus 1, sum equals count. If the same operator is used as a postfix operator, as in sum equals count plus plus, the assignment of the value of count to sum occurs first, then count is incremented. The effect is the same as that of the two statements. Sum equals count, count equals count plus 1. An example of the use of the unary increment operator to form a complete assignment of statement is count plus plus, which simply increments count, but it does not look like an assignment, but it certainly is one. It is equivalent to the statement count equals count plus 1. When two unary operators apply to the same operand, the association is right to left. For example, in minus count plus plus, count is first incremented and then negated, so it is equivalent to minus count plus plus, rather than minus count plus plus. Here we have an example for C, C, and C++. Int A, then A++. And for Java, int A equals 1, A++. For Java, you have to initialize the value of the variable first before you can increment or decrement it. Here, I will demonstrate the unary statements on C. As you can see, I've already initialized both A and B as 1 and 2 respectively. Then, I wrote here A is equals to B plus plus, and then print A. I will demonstrate the difference between B plus plus and plus plus B. First, we'll see the output of B plus plus. As you can see, the output is 2. Then, we'll edit this to plus plus B, and then run it. As you can see, the output is now 3. So there is a difference between plus plus b and b plus plus. Assignment as an expression. In the C-based languages, Perl and JavaScript, the assignment statement produces a result which is the same as the value assigned to the target. It can therefore be used as an expression and as an operand in the other expressions. This design treats the assignment operator much like any other binary operator, except that it has the side effect of changing its left operand. The disadvantage of allowing assignment statements to be operand in expressions is that it provides yet another kind of expression side effect. This type of side effect can lead to expressions that are difficult to read and understand. An expression with any kind of side effect has this disadvantage. Such an expression cannot be read as an expression, which in mathematics is a denotation of a value, but only as a list of instructions with an odd order of execution. For example, the expression a equals b plus parenthesis c equals d divided by b close parenthesis minus 1 denotes the instructions assign d divided by b to c, assign b plus c, to temp assign temp minus 1 to a. Note that the repeat of the assignment operator as any other binary operator allows the effect of multiple target assignments such as sum equals count equals 0, in which count is first assigned to 0 and then count's value is assigned to sum. This form of multiple target assignments is also legal in Python. There is a loss of error detection in the C design of the assignment operation that frequently leads to program errors. In particular, if we type if parenthesis x equals y instead of if parenthesis x equals y close parenthesis, there is a loss of error detection in the C design of the assignment operation that frequently leads to program errors. In particular, if we type if parenthesis x equals y instead of if parenthesis x equals y. Here we have examples for C, C++, and Java for assignment as an expression. Int a, b, c, and then a equals b equals c equals 1, which means that c is assigned 1 and then b copies c, which is 1, and a also copies b, which is 1. In the second one, int d equals a plus c equals a divided by b equals 1, which means that a and b is first divided and then assigned to c, and then a plus c and then minus 1, and then the total of that is assigned to d. Here I will demonstrate assignment as an expression on Java. As you can see, I've already declared and initialized a, b, and c. This is an example of assignment as an expression. A is equals to b equals to c equals to c. How this works is c equals 1 will be the first one to assign, and then b will copy c, and then a will copy b. And then I will print out all three variables here. Next, here in int d equals a plus parenthesis c equals a divided by b minus 1. How this works is a, which is 1, plus c, 1 equals 1 divided by 1. This is c is 1 because it is initialized as 1 divided by 1, which is a and b both. And then 1 plus 1 is 2 minus 1. Of course, the answer will be 1. Here we can see the results of the program. We printed all a, b, and c, which is 1, 1, 1, and then we printed d as the result of all of this assignment as an expression, and we got the output 1. Now I will demonstrate what will happen if I were to change this code and assign a as 2. Now this one will be 2 and this one will be 2, and since 2 divided by 1 is 2, then the output will now be 2 plus 2 minus 1, that will be 3. So let's check the output. Here we can see that a is now number 2 as we have changed it here, and our assumed output is correct, which is 3, and so therefore this assignment as an expression works. Multiple assignments. Several recent programming languages, including Perl, Ruby, and Lua, provide multiple target, multiple source assignment statements. For example, in Perl, one can write $first, $second, $third equals to 20, 40, 60. The semantics is that 20 is assigned to first, 40 is assigned to second, and 60 is assigned to third. If the values of two variables must be interchanged, this can be done with a single assignment, as with first second equals second first. This correctly interchanges the values of first and second without the use of a temporary variable, at least one created and managed by the programmer. Mixed mode assignment. Frequently, assignment statements are mixed mode. The design question is, does the type of the expression have to be the same as the type of the variable being assigned, or can coercion be used in some cases of type mismatch? The design question is, does the type of the expression have to be the same as the type of the variable being assigned, or can coercion be used in some cases of type mismatch? Lastly, here I will demonstrate mixed mode assignments on C++. Here I've already initialized a, which is equals to 1 plus 1.0. What I'm doing here is adding a integer with a double or float number, and you will see that everything is it still works. The output is still 2. This is mixed mode assignment, that you can use more than one data type for assignment.